Hello, my name is Caleb, and this is Lab 1 Charge Tapes. The purpose of this lab is to understand the interactions between two charged pieces of tape. GlowScript is used as a computational model to simulate the interactions and compute the charge of the tape and find the number of electrons lost during the experiment. Some of the findings and results include the tape being positively charged, the number of electrons the tape is deficient by, and the electric charge of the tape. Some of the fundamental principles we used were Newton's second law, which we used to relate the gravitational force to the electric force, and Coulomb's law, which we used to isolate Q in order to determine the charges of the tape. This is a demonstration of the model that was used to conduct the experiment. The initial conditions were the tape mass, which was 2e to the negative 4 kilograms, the tape length, which was 0.2 meters, and the tape width, which was 0.02 meters. The distance between the two tapes was measured out to be 0.025 meters during the experiment, and the tape was determined to be positively charged because of its attraction to a hair-charged pencil. This is the GlowScript code that was used for the experiment. As you can see, the initial conditions are on the left side here. They include Coulomb's constant, the charge of an electron, the force of gravity, the length of the tape, the surface area of the tape, the mass of the tape, the distance that the tape moved during the experiment, and the area of an atom. The code in the center is the main code that was used to make all of the calculations. The code on the bottom is the code that was used in order to model out the equations that we used. Here are the results of the experiment using our code in GlowScript. As you can see, there's a model on the left with all of the information that we calculated on the bottom. The magnitude of the electric force and the gravitational force came out to be the same, which was expected due to Newton's second law. It was 1.96 e to the negative 3. The charge of the tape was calculated to be 1.16 e to the negative 8. The number of electrons lost was calculated to be 7.29 e to the 10. The area of the tape was 4 e to the negative 3. And the ratio of electrons to atoms was 1 to 5.48 e to the 6. What if and why? If the charges of the protons and electrons were switched, the observations wouldn't change. However, instead of the electrons being lost, it would be the protons that would be lost instead, because they're the ones with the negative charge. All other findings throughout the experiment would remain the same, because nothing except for the charges would be switched. And is it important to handle the charged tapes as little as possible? Yes, it's important to handle the tape as little as possible, because the charge of the tape could be affected by the charges of surrounding objects, including our hands. This happened multiple times during the experiment, which caused us to have to start again with another piece of tape because of the loss of charge. Finally, some possible errors include an inaccurate measure of the length or width of the tape, an inaccurate measure of the change in distance of the tape, and the way the tape was held and the loss of charge on the tape due to our body's own charge.